Okay, hi everyone. This is question 5. I'm quickly knocking up for you. So let me draw it first. Always got to draw it. Even though you're given the diagram, draw the thing out. Like I can't emphasize it enough. And I remember my old maths teacher saying the same thing to all of us lazy kids as well when we were at school. Um, Nobody wanted to draw it. You have to draw it. It's impossible without drawing it. Okay, well, first thing I'm going to do as well, and this is largely a matter of taste, but it just doesn't make as much sense to me. Like whenever they show an arrow on a diagram which is a push, yeah, I like all of my forces coming out from the object. Now this is largely a matter of taste, it really is. So when they draw that 49 newtons pushing into the object, I prefer it coming out of the object. I like all of my force arrows coming out of the object. I just like consistency, that's what it is. And so I don't want some pushing in and some pulling out. So I just move this arrow over here. Now, as that was theta, this is still going to be theta. And so I can now just get rid of this pushing in and just have all of my arrows pushing out. I just like to do that. It just makes more sense to my tiny brain. I just prefer it. But it is a matter of taste, and you don't have to do that. So that's what I'm going to do first with the 49 newtons. I'm going to move it so it's happening on the other side of the object. And then what else have we got here? Well, we've always got a reaction force, which is perp to the plane. A contact force, remember, that's what that is. We've always got the weight, and this is 6 kilograms, so that's going to be 6g. I like to also point out that this is going to be the same angle as that, so that's going to be 30 degrees. And then have we got anything else? No, because it's a smooth plane. It's a smooth plane. Great. Well, I'm happy with that. Now, it says show that cos theta equals 3/5. Well, it's in equilibrium. So we can do things like ups equals downs and lefts equals rights, but I'm going to do it parallel to the plane. Let's try parallel to the plane, the lefties equal righties. We'll have 6g sine 30 equals 49 cos theta. 30 I've written there, but it's theta. Now, why am I writing that down? Well, let's just show you with a bit of colour. All I'm saying here is that the forces acting to the right equal the forces acting to the left. So that 49 cos theta represents the forces acting to the right up the plane. And the 6g sine 30 represents the forces acting to the left down the plane. And then, well, you can easily get the answer from there. I hope this gives us the right answer anyway. Let's just see. 6 times 9.8 times by a half, and then divide it by 49. Lo and behold, I get cos theta equals 3/5. You might think that's kind of weird, but that's because that's a 5g, I think. So we end up with 3g here because sine 30 is a half. So we 3g divided by 5g is 3/5. Okay, so there we go. Let's do B now. Okay, part B. Find a normal reaction between P and the plane. Well, this is just going to be operating in the other direction. Oh, we're looking in that direction now. So we can say that R equals 6g cos 30 plus 49 sine theta. Now, if cos theta is 3/5, you could use, for example, there's lots of ways of doing this. You could draw out a little triangle, or you could use sine squared plus cos squared is 1. And you'll quickly see that sine theta is going to be 4/5 there. And so R equals 6g cos 30 plus 49 times 4/5, which equals, I'm doing it on my calculator, 6 times 9.8 times cos 30 plus 49 times 0.8. I'm getting 90.1 newtons. And then in part C, what's going on now? The direction of the force of magnitude 49 newtons is now changed. It is now applied horizontally. So what do? We draw it out again. Yeah, do not be lazy here. Draw the diagram out again. It doesn't take a second. And you get good with doing these diagrams as well, which is kind of important. So it only takes a second. So which way is the 49 newtons now going? It's now applied horizontally to P so that P moves up the plane. So horizontally to me, so that it moves up the plane, suggests it's going in that direction. It's not going straight up the plane, otherwise they'd be saying parallel to the plane. And so that's going to be 30 degrees because this is 30 degrees. You've got the weight, which is still 6g, but remember that that is going to be 30 degrees. And then we've got R, which is there. The whole thing changes basically. When you change the direction of a force, or you remove a force, or you add a force, you have to start again. It's just start again. Yeah. Okay, so the force acts in a vertical plane through a line of greatest slope of the plane. That's just saying that it's directly in that direction. It's an issue with 3 dimensions rather than 2 dimensions. It's easier to sort of explain that when I'm face to face with you, really. But yeah, so just you can almost ignore that sentence in the question. Find the initial acceleration of P. Okay, so you might wonder, well, which force is stronger, the 49 cos 30 or the 6g sine 30? Well, 6g sine 30 is just 3g, and 49 cos 30, I've written 36 there. What am I doing? Um, let's actually work that out anyway as 3 times 9.8. If you work that out on a calculator, you get 29.4 newtons. And all I'm doing here is I'm trying to decide which one's a stronger force, whether it's going up or down the plane. 49 cos 30. I reckon it's probably going to go up. I think it might have even said that in the question. It's 42.4, but I can see it must be going up now because that force is stronger than this force. So how am I going to find the acceleration? I'm going to do stronger force minus weaker force equals mass times by the acceleration. And now I can find the acceleration by just doing that. Minus 29.4 divided by 6. Okay, I'm getting an acceleration of 2.17 meters per second squared. Hope that was helpful. Well done for keeping up with these videos, and yeah, best of luck with the rest of the work. Bye bye.